Welcome to Math 8.2. And this learning target is going to be extend and describe arithmetic sequence using algebraic expression. There's a lot in it. So extend means to take, okay, you get some inputs, let's extend it to the outputs. And let's see what the sequence keeps doing on. Like 1, 2, 3, 4, the next one would be 5, then 6, then 7, and you're adding 1 each time. So I'm extending the sequence, describing what's going on, what's the function. If I go from 1 to 2 to 3, I'm adding 1 each time. So I'm describing. So I'm extending it, describing what's happening in these arithmetic sequences. I needed to define that for you, and I will. Using algebraic expressions. We know what algebraic expressions are. It's like x plus 4, y minus 2. It doesn't have the equal sign. Then it becomes an equation. But if it's just an algebraic expression, it's just what's the function. Without the equal, what's the function? Okay, so let's talk about two different types of sequences. You have an arithmetic sequence, and this is when you add the same number to the previous term. So it's adding. Here's the key. Adding. Okay? So an example, 3, 6, 9, 12. What am I doing to each one of these? Am I multiplying them? Am I dividing? Am I subtracting? Am I adding? What am I doing? I know it's getting bigger, so I'm either adding or multiplying. Now, if I was multiplying, it'd be times 2. 3 times 2 is 6. 6 times 2 is 12. Oh, that can't be it. Now let's try adding. 3 plus 3 is 6. 6 plus 3 is 9. 9 plus 3 is 12. So my rule is plus 3. I can say any number plus 3 will keep me going here. Okay? So now 12, I could extend it to 15, to 18, and on and on and on. Okay, so that's an arithmetic sequence where you add. Let's go to a geometric sequence. Geometric, okay? Each term is found by multiplying, okay? Arithmetic adding, geometric multiplying. The previous term by the same number. So here's an example, 3, 6, 12, 24. Looks kind of similar to this one. Maybe I'm just adding 3 again. That'd be 6. 6 plus 3 is 9. Nope. Now, let's try multiplying. 3 times 2 is 6. 6 times 2 is 12. 12 times 2 is 24. So it's 2 times a number. Okay? So, the rule is times 2. Now, I could extend it. 24 times 2 is 48. 48 times 2 is 96, and I keep going on and on and on. Geometric sequence, as you can imagine, with multiplying, is going to get bigger more quickly and in the long term. Adding, you're just adding. So arithmetic, they're kind of slower, but they're going up. This one goes up more quickly. Okay? I have 2 examples here I'd like to practice. I need to figure out what is it, and what are the next 2 numbers, okay? So let's look at this one. I can see a 0 here. If I was thinking this was geometric, I can eliminate that right away because 0 times anything is going to be 0. This sequence would have to be 0, 0, 0, 0, 0. So it can't be multiplication, it has to be adding. So it's arithmetic because it's getting bigger. So what do I do to go from here to here? Plus 15. Now if this works, plus 15. 15 plus 15 is 30. Plus 15, 45. There's my function. I'm adding 15. So now I'm going to get 2 more. This one and this one. 45 plus 15 is 60. 60 plus 15 is 75. And I could keep going on and on and on. Okay? So this is a AS, arithmetic sequence. Let's look here. 1 to 3 would be plus 2. 3 plus 2 would be 5. Doesn't work. Must be multiplication. 1 times 3 is 3. 3 times 3 is 9. 9 times 3 is 27, and on and on. So this one is a geometric sequence because it's multiplying. Now let's go with 2 more. 27 times 3. You can use your calculator for these because they get bigger quicker and they're, a little bit easier. 21, 6, 7, 81. And then 81 times 3, 3, 2, 43. Okay? So we took it 2 more out. All right. So that is how you look at sequences, and decide, are they arithmetic or are they geometric? Okay? All right. Now, let's go over here. Here's where the algebraic expression, okay? Over there in our learning target, we just did the first part. We did extend and describe what's going on. Now, we need to describe them using an algebraic expression. Okay, this is where it gets a little bit tricky, but if you remember 8.1, where we did those tables like this, and you had your input, which was x, you had your function here, and you had your output, which was y, okay? So all we're trying to do is figure out what is this. Now this gives us the position and the value. The position is the input. So in this one we have 2 goes in, and we have 12 comes out. Here we have 3 going in, and we have 18 coming out. We have 4 going in, 24 going out, 5 and 30. And then this last one, it says n is going in, what's coming out? Well, once we know this function, we can put any number in here and get the output. So this is the function. This is the key right here. Once we figure out this, then we'll know what that could be, okay? Because we could say maybe n is we'll say it's the 10th term. So our sequence is, here's the first term, second term, third, fourth, fifth, sixth, all the way up to 10th, okay? Now, here's the tricky part. I look at this, and I say, well, 2 to 12 could be plus 10, x plus 10. Because if I put 2 in here, 2 plus 10 is 12. Perfect. So let's do x plus 10 here. Because this function has to be the same for all of them. There is one function that works for all of them. 3 plus 10 is 13. Okay. It doesn't work for one. It doesn't work for any. All right. One thing I'm kind of looking is I'm going over on this side. I'm thinking, what's going up here? 12 to 18. That's getting 6 bigger. 18 to 24 is another 6. 24 to 30 is another 6. So every time I go up, I'm multiplying by a 6. So I'm going to try 6 times x. So I put my 2 in here. Let's see if it's 6x. Put my 2. 6 times 2 is 12. Then I put my 3 in here. 6 times 3 is 18. Good. 6 times 4 is 24. 6 times 5 is 30. Okay? Basically what I was doing is I was looking from here to here, what's happening? It's being multiplied by 6. 2 times 6 is 12. 3 times 6 is 18. 4 times 6 is 24. 5 times 6 is 30. And it can go on and on and on. So the rule, the function rule, is 6n. 6 times any number. So say I do want to do 10. I put 10 in there. 10 times 6 is 60. Then I can find any number in this sequence. I don't have to do it like in order like this way. I can just say, whatever my number is, times 6, that's my output or my value that I'm looking for. Okay. Let's look at this one here. So I could do a table like this, where I have the in and the out, and I have the function. There we go. Okay. This one I have 3, 4, 5, 6, and then n. And here I have 7, 8, 9, 10. Okay. So if I look over here, it's going up by 1 each time. That doesn't really help me. I'm going to start by going, what do I do to go from 3 to 7? Well, I take x plus 4. So this is my first attempt. It's a guess and check kind of thing. Because 3 plus 4 equals 7. Now 4 plus 4, does that equal 8? Yep. 5 plus 4, 9. 6 plus 4, 10. Cool. I got it pretty quick. I got my function. I just went from here, what goes in, what happens to it, and what goes out. Okay? There's going to be a lot trickier ones than these two that we just did, where you might have a bigger algebraic expression. So we'll work on those. Those get tricky, where it might be like 2 times n, or 2 times x plus 4. And those are tricky, but we'll work on that. So let's look at the rule on this one. The rule, or the function, is n plus 4. So if I wanted this to be 10, 10 is my position. I put 10 in here as n plus 4, it's 14. I could put 100 in here. I don't even need to go in order here. 100, I put that in. 100 plus 4 is 104. In this sequence, that's what I'm going to get. And you might say, well, I have this little sequence going here. I want to know not at the 6th position, but what if I go to the 1,000th position? What is it going to be? So instead of having to go 7, 8, 9, 10, 11, 12, all the way to 1,000, you find out what's happening to the same number and then put your little algebraic expression and plug in your numbers. Okay? This is really important, really tricky, really, you got to think a lot about this stuff. But go ahead and watch the guided practice and see what you can do. If you have any questions, let me know. These are the sequences, the arithmetic and the geometric sequences, and how to find out what the rule is when you have a position and a value. Okay?